we got lesson 3 in trigonometric identities and equations. Today we're going to be looking at some basic identities, learn about what they are, and yeah, let's take it from there. So basically, what a trig identity is, it's basically an equation that's been proven true for all related trigonometric ratios. Okay, so the key thing here is that you're basically looking at an equation where the left side and the right hand side supposedly equal each other. Okay, you need to prove that by using your knowledge of trig identities, which I'll show you in a moment, so that you can get the same quantity on both sides. All right, so what does this mean for us? Well, in order to prove an identity, we're going to use basically what we call some basic axioms that we assume to be true all the time. So what this means is these facts that you already know, these reciprocal identities, that cosecant is 1 over sine theta, secant is 1 over cos, and cotangent is 1 over tan, you're going to assume that these are always true. All right, so that's good news. And you also know, conveniently, that tangent theta, another way to write it, remember it is y over x, and y and x are sine and cos on the unit circle. So tan theta is sine theta over cos theta. And so therefore, cotangent theta, if you do the reciprocal of this, is cos over sine. So using these 5 facts, we are going to prove some identities. Now, what does it actually mean to prove an identity? Well, it means that any value of theta for which the identity is defined for works, okay? Now, that's a tricky thing when you think about it. Right now, I'm just going to do an example where I'm just going to plug in one possible value for theta into, say, this identity and just show you that it works, okay? Now, we're going to use this terminology of LHS, which stands for left-hand side, and RHS, which stands for right-hand side. So, here we go. Let's do it. And where are we here? Boom, boom, boom. So we're going to go ahead and plug in theta is pi over 4 into this identity here. So your work might look something like this. So you're going to go sine pi over 4 times secant pi over 4 and then times cotangent pi over 4, and this supposedly equals 1. Now these are all exact values, so when sine is at pi over 4, the y value is square root 2 over 2 times secant. Remember, secant's 1 over cos theta, so they might as well be asking me what is 1 over cos at pi over 4. Well, cos at pi over 4 is square root 2 over 2. Now when you go 1 over that, you're just going to end up flipping it. So you're going to get 2 over the square root of 2. Cotangent, remember we just had it on the other page, and it is, let's see, it's cos over sine. Now, the whole point of this is cos and sine at pi over 4 have the same value, right? So when you have square root 2 over 2 divided by square root 2 over 2, you're just going to get 1. Now, is that equal to 1? I guess I'll put a question mark. So here you can cross reduce. You're going to get 1 on top, 1 over here. Square root 2 divided by square root 2 is 1. So you just have a bunch of 1s multiplying each other everywhere. So you have 1 equals 1, and indeed that works. Now, that's part A, where we're just verifying that the identity works for one value. That's not a proof. To prove the identity, I actually need to manipulate the left-hand side so that I get 1. This is not a typical equation, okay? You are not allowed to move things from one side of the equation to the other because you're doing a proof. Okay, so I'm not allowed to say manipulate this and divide it by cotangent theta on both sides. Basically, you're allowed to manipulate the left-hand side independently of the right-hand side. So you can manipulate both sides, but you're not allowed to take one term and move it over here, okay? So that's a very important difference between this and a regular equation. So what we do is we set up these tables, and to help you solidify the concept that you can't cross terms from one side to the other, we put this big black line down the middle and kind of say nothing crosses this line. So on the left-hand side, we got sine theta, secant theta, and cotangent theta. And on the right-hand side, we have 1. Okay, so what we can do is maybe we can substitute something in for all these values. So like for sine theta, I'm going to leave that alone. But I know that secant theta is 1 over cos theta. And I know that cotangent theta is cos theta over sine theta. All right. Now, again, I can't move anything to the right-hand side, but I am allowed to manipulate what I have here. So if anything cancels, like I got cos theta divided by cos theta, so that's 1. And I also have, I'm going to just throw this over 1. I got sine theta in the top and sine theta in the bottom. So those will divide out to 1. So once again, you're in the situation where you have 1 times 1 times 1 divided by 1 times 1 times 1. So you just get 1. And you just keep carrying down this. So there we go. I've shown that the left-hand side equals the right-hand side without crossing any terms over. So that would be the actual identity. We got another one. Now to save some time, I'm not going to plug in and show you that it works for pi over 4. Just believe me that it does. But I would like to prove the identity. Okay, so this time we have things on both sides, and we need to show that the left-hand side is the same as the right-hand side. So right off the hop, now you don't need to rewrite this. I'm not going to rewrite it down here. Okay, good. But I am just going to start doing what I can. This looks kind of complicated, so I'm going to leave the left-hand side alone for now. But on the right-hand side over here, I'm going to just go and write 1 plus, what is the definition of cotangent? So cotangent is the usual cos theta over sine theta. Okay, now you'll get lots of practice on these, and it's imperative that you do if you're going to get good at them, because part of proving an identity is you need to be a little bit good at looking ahead and being like, okay, where am I going to go with this? There are multiple ways to prove an identity, usually, especially the ones they give you on the exam. So I'm kind of looking at this, and I'm looking at the left-hand side, and I'm wondering, well, can I make them look the same? Can I make them equivalent? And right now, this 1 is really stopping me from, it's very different, right? Like I got this fraction, and then I got this 1. So I'm going to write 1 as sine theta over sine theta, right? So as long as it's an equivalent form of 1, and that is, now maybe I'll be able to do something on the right-hand side. So I now have a common denominator, actually, and I can kind of write, okay, just write it all as 1 fraction. So in the numerator, I got sine theta plus cos theta, and my denominator is sine theta. And lo and behold, that's exactly what I got on the left-hand side. So if you want to save yourself some time, you can just write left-hand side equals. You don't have to recopy it. Even on the exam, you're allowed to do that. All right. Before we go on and do anything else, I am going to do some algebra review with you guys. So we're going to be working with a lot of fractions, and those fractions are going to involve the trig ratios. So just in general, let's just make sure we're okay working with fractions, and we'll just use letters. So it says write each expression with a common denominator. Okay, and it's just specifying that all these things are not equal to 0. So if you want to skip this part of the video, fine. If you think you're very comfortable with this stuff, you might want to check it out. But our goal is to write each thing as just 1 fraction. Okay, so common denominator here would be b times c. Okay, so over here, I'm going to multiply this by a form of 1. So b over b. I'm going to multiply this one by c over c. And over here, I'm going to get ac plus bd. Or sorry, it's b times b, so b squared. Over, and we have our common denominator c times b or c or b times c. So I'm going to write it in alphabetical order, so I'm going to go b times c. There. So that one's done. This one here, this one's going to have some factoring. So in the top, it looks like I can pull out an a. So if I pull out an a and divide a squared by a, I get a, and then subtract a times b divided by a, so I'm just left with b. So there's my numerator. Down here, this is looking like a difference of squares, right? So I can write it as b minus a times b plus a, and you're kind of thinking, well, does anything cancel? And the answer is yes. Remember that trick where you can pull out the negative and switch the order of 2 terms? So I can pull out a negative here, make it negative a. And if I pull out the negative, then over here I'm going to get negative a plus b, right? As long as I multiply that negative back in, I'm back to where I started. But now this allows me to switch the order of these things, so I can write it as b subtract a over this stuff down here. So b minus a, b plus a. And I can say, oh, I got the same binomial, those cancel out. Good thing you had an amazing teacher in grade 11 pre-calc. And there you go. So you get negative a over b plus a. That is ugly. All right, we got a couple more. Now this one here is one that happens to us quite frequently in grade 12. Okay, so just watch out for it. When you have a fraction divided by another fraction, the trick you guys actually learned in grade 9 was you can change it to multiplication as long as you do the reciprocal of whatever's in the denominator. Okay, so the reciprocal of that would be d over c, and now I can just multiply across and I get ad over BC. That one actually doesn't end up being so bad. Now, this one here, well, we got a fraction in the top and then divided by another thing with a fraction. So the first thing we're going to want to do is get a common denominator in the top. Okay, so common denominator is going to be b times c. Remember, I'm just going alphabetical order here. Okay, so this one I'm going to multiply by c over c. This one I'm going to multiply by b over b. And just looking ahead in the bottom, we're probably going to have to get a common denominator down here as well. Common denominator is going to be a. So this one, which is b over 1, I'm going to multiply by a over a. Remember, I'm allowed to do this because it's a form of 1, and I'm not really changing anything. So in the top, we get a times b plus 1 times c, which is c. Let's write our common denominator as b times c. Divided by, in the bottom, we have ab plus c over a. And now this question looks a lot like this one here, where we have a fraction in the top and a fraction in the bottom. So we merely recopy the top fraction, multiply it by the reciprocal of what's in the bottom. So there we have it. Now, if anything cancels here, do it. So this is a binomial that's in the numerator, and the same binomial appears in the denominator. So I'll be able to divide those out to 1, leaving me with 1 times a in the numerator, and then b times c in the denominator. There you have it. So we'll be manipulating things like this, but there'll be trigonometric ratios involved. Maybe we went slightly harder than we need to, but that's not a bad thing. Again, I think this is the most common one that happens as far as the trig identities I've seen on the exam. And that's probably about it. You also have a lot of things like, that'll be like 1 plus some sort of fraction. That's another common one that happens, and you saw how to deal with that on the last slide. Alrighty, so let's go do some identity proofs. We're going to be proving them for all values of theta, and what else? Yeah, we'll basically prove it. They do tend to give you, on the exam, they give you that left-hand side, right-hand side sort of table, so we'll just make our own this time. And they will usually also ask you about non-permissible values in the original identity, so just watch out and make sure that you don't get any values of 0 in the denominator. So in this case, secant is 1 over cos theta, so you're going to end up not having a denominator here, so there's no non-permissible values we really need to worry about. And let's see, when in doubt, just start somewhere. Okay, so as you're just starting out doing identities, one of the questions is like, where do I start? And my answer is just start doing something. Okay, now this is cos squared, which we don't really know a lot about right now. We will have some identities later that we can use, but today we don't really know anything. So I'm going to start over here on the right-hand side instead and see what I can do. So cotangent, just recall, is cos theta over sine theta. So generally you'll be plugging in and getting rid of your non-regular trig identities. And then you have times sine theta. Just going to write it over 1. So that's the numerator. Now in the bottom, you have 1 over cos theta because that's secant. Okay, so if I'm going to get to cos squared theta, I'm going to have to probably just multiply by the reciprocal of this. Okay. Also, I'm noticing that in the numerator, I got a sine theta in the numerator and a sine theta in the denominator. So I can cancel those out to 1. Okay, so in the numerator, I basically just have cos theta, and it's divided by 1 over cos theta. By the way, when you're doing a proof, it's very important that you show all your steps. Okay, so don't ever skip when you're canceling things. Like, make sure that you're crossing them off and clearly showing it. You're doing a proof, and you need to show every step. Okay? So, next step would be take my numerator, multiply it by the reciprocal of the denominator. So I have cos theta over 1. And cos theta times cos theta would be cos squared theta. Note how we write it. The squared comes before the theta symbol. It's just the way that we write it. It's just a notation thing. So now I can write on the left-hand side. You don't need to recopy it all the way. You can just go like this. You don't even need the arrow. You can just rewrite it. And there I've showed that the left-hand side equals the right-hand side. So that's wonderful. So let's move on to the second one. So I'm going to draw as straight a line as I can. Now this one's looking pretty complicated, but on the right-hand side, remember that secant is 1 over cos theta. So I have sine times 1. So I have sine theta in the numerator, and I have cos theta in the denominator. Just recall this is also tangent theta, so just watch out. Now we do have a tan theta over here. On the left-hand side, go ahead and replace anything that you can. So tan theta is sine theta over cos theta. And in the denominator, I have 1 plus cos theta. Now this is looking really ugly, and it's not very obvious what I should do. I think I'm going to get a common denominator in the numerator. That was the general strategy we were doing before when we were doing the algebra questions, right? So I'm going to multiply this one by a form of 1, which would be cos theta over cos theta. So right here, I'm going to get sine theta cos theta, plus right here we have sine theta, right? And the common denominator in the top was cos theta, and it's all divided by 1 plus cos theta. Now this is looking pretty ugly, but I'm trying to basically get rid of this thing down here if I can. Now in the numerator, I'm noticing that I got a common sine theta, so I can pull out that sine theta, and that would give me cos theta, plus, when you go sine theta divided by sine theta, you get 1. Now remember, that's divided by cos theta. And all divided by 1 plus cos theta. Again, you're kind of looking at this and it's like, this is looking worse and worse. But check this out. I got a cos theta plus 1 and a 1 plus cos theta. That is the same thing. So I'm just going to recopy this. And I'm just going to rewrite this as 1 plus cos theta. Right? It's the same thing. Doesn't matter the order that we add 1 to something. In that case. Now down here, I'm going to go ahead and do the reciprocal of this. I'm going to multiply by the reciprocal of this fraction, which is 1 over 1 plus cos theta. Now look at that. I got 1 plus cos theta and 1 plus cos theta in the top and the bottom, so I'm going to cancel them out. This is just 1, and I'm just left with sine theta over cos theta, which is what I have on the right-hand side. So you can just write equals right-hand side. Now that's a particularly tricky one, but there you have it. That's what happens, man. It's the way it be sometimes. Okay, what do we got here? Ooh, some more. Sure, let's do, I'm not going to do both. I think I got 2 lined up here. I'm not going to do both. The first one is quite easy, and I sort of suggest that you try it out yourself. What you're going to want to do. Let's just do it. So let's just do it. So cotangent is what? It's 1 over 10, right? And tan is sine over cos. So when you do the reciprocal, cotangent is cos theta over sine theta. So that's great. Let's replace that. And whoops, so I'm going to write cotangent as cos theta over sine theta. Now cosecant is 1 over sine. Right? So I'm just going to write divided by 1 over sine theta. Now, draw my little line here. So I'm trying to get all of this equal to cos theta. So this is pretty straightforward, like I said. Very similar to the algebra questions we were doing. So take cos theta over sine theta, multiplied by the reciprocal of the bottom here, and now you can cancel out your sine thetas, and you're just left with cos theta, which equals cos theta over here. So that one was easy peasy lemon squeezy. This is the one that I wanted to do with you guys. It's sort of similar to that one that was kind of tricky. Anytime you start seeing fractions like this, you start getting nervous and you start sweating and stuff, and ooh, it's ugly. But, I'll show you how to deal with it. So for part B, when you have a fraction, like if there's any of the non-primary trig ratios, you're going to want to replace those right away, and then you're generally going to want to get a common denominator in the top or the bottom or both. So secant theta is 1 over cos theta. Okay, so you got this 1 here. So I sort of recommend get maybe a common denominator going here would be my suggestion. So you can multiply this 1 by cos theta over cos theta. Right? And then in the bottom here, so I'm going to recopy my numerator. In the bottom, if you had cos theta over cos theta, in the numerator you'd have cos theta plus 1. Over, remember our common denominator in the bottom was cos theta. Now this is allowing me to go ahead and multiply the numerator up here which I will write in brackets. I can multiply it by the reciprocal of the denominator, so I can go cos theta over, remember cos theta plus 1 and 1 plus cos theta are the same thing, so I'm just going to go ahead and write it like that. So there you have it. Write this as being over 1 if it makes you feel better. So in the numerator I have this, and in the denominator I have that, so that's going to divide out to 1. So I just have 1 times cos theta divided by 1. So I just have cos theta, and that's what I was trying to get on the left-hand side. So that one worked out just dandy. Woo! Replay it, try it again, stick with it. Basically the best thing you can do in the identities unit is to do lots of practice, to do all the homeworks, do all the supplemental exercises. The more the better, because the more of these you do, the more experience you get. And you'll just get better at it. Because there is no like, hey, this is what you do every time kind of strategy. You just need to know your stuff. So I kind of wrote this title in as dealing with reciprocal trig functions and identities. We've already been doing that for the entire lesson, but just to maybe write it out formally. So cosecant is 1 over sine theta. Secant is 1 over cos theta. And cotangent's 1 over tan, right, which we thought as cos theta over sine theta. So useful to think of it either way like that. Right, so now basically we're going to solve some more identities. Or actually, rather, no, we're switching to equations here. So, right, my mistake. Sometimes you're going to do equations. So just like we were doing in lesson 1 and 2, you have actual equations. So notice how this is not an identity, right? It would say prove the identity. In this case, it's saying solve this over the domain 0 to 2 pi. If you get one of these, this is about as tricky as they get for trig equations. Okay, so this is a trig equation, not an identity. And your best bet is the strategy is replace the non-primary trig ratios. And if you're sitting there being like, what are the non-primary trig ratios? It's the 3 we just reviewed above. Secant, cosecant, cotangent. So I'm going to leave this side alone. So I guess I'm just going to recopy it. But I'm going to write secant as 1 over cos. So I'm going to have 2 over cos theta, right? Because 2 times 1 over cos theta is 2 over cos theta. And now I can multiply both sides by cos. Ooh, don't do what I just did. I just changed the variable. That's going to lose me half a mark if that was the exam. The variable is x, so make sure you keep it as x. So there we go. So I'm going to multiply both sides by cos x. Use brackets over here. All right, so that's going to divide out to 1. So now I have this equal to 2, and I got cos x. Going to have to distribute this into the brackets. Right, I'm going to have to bring the 2 over here, so I'm going to get 3 cos squared x. That's this one times this one, and then 1 times cos x gives me cos x. Okay, now move this over here. So I get 3 cos squared x plus cos x subtract 2 equal 0, right? So you need to do that so you have it equal to 0, and now you can factor this thing. Now you might want to pause it here at this point, and you're going to be doing the decomposition, right? So 2 numbers that multiply to -6 but add up to 1. Okay, I'm not here to review decomposition, so I'm just going to jump straight to the answer that I got. So just pause the video and make sure you get this answer and then keep going. So you're going to get 3 cos x minus 2, and then cos x plus 1, and that's equal to 0. Okay, so now you can do the 0 product property, right? And you can solve this first equation equal to 0, and you can solve this second equation equal to 0, and then give me some values here. So this one is going to give you cos x equals 2/3. And that is a non-exact value. So when you go find your reference angle, you're going to go pop that in on your calculator. I'll let you know the answer in a moment. So that's going to give you an answer of, let's see, for my reference angle, I got 0.841. All right. Now, where is cos positive? okay, because we're looking at positive values of cos because our ratio is 2/3. So that's going to be, just sketch a little diagram. Cos is positive in quadrant 1 and in quadrant 4. So one of your answers will be 0.841. Right, in quadrant 4, if you sketch that and you rotate around, this is your reference angle. We're doing this in radians, so this is 2 pi. So you can write x equals 2 pi, and then you have to subtract the reference angle. So pop that in on your calculator, and you're going to get, I got 5.442. So there's the two solutions on 0 to 2 pi for that branch. Go back and don't forget about the other branch. So this one here gives us that cos x equals -1. So when you find your reference angle, you are looking for where it's equal to -1. Now remember, this is one of the sort of ones on the extremes here. So where is cos -1? There's only the one place over here at pi, right? This is where the coordinate is -1, 0. So you get that x equals pi right here. And you are done. You got your 3 solutions done. Yeah! All right. Got another one. This title should really say in equations, not identities, like I said. So I'm very sorry for that. When I was going through the notes adding titles, I missed that. So yeah, you can't solve it if you have sine and cos in it, right? So you're going to have to do something. And the best thing that I can think of in this one is, remember, this is an equation, not an identity. So I could divide everything by cos x. And I know that doesn't seem obvious. And this is slightly harder than what you might get on the exam, but I'm glad that you're going to get the opportunity to see this. So that would divide out to 1. This is going to give me tan, right? So now I have tan plus square root 3 equals, 0 divided by cos x is still 0. Now you can solve this for tan x. So you get negative square root 3. Find your reference angle. Again, this is a non-exact value. Get used to it. It's going to happen to you quite a bit on the exam. So when you plug that in on your calculator and get your... oh no, this isn't a non-exact value. This is an exact value. Right, on the unit circle, right here at pi over 6, this is where the tan value is actually equal to square root of 3. Okay, so the reference angle is going to be pi over 6. Now, we're looking for where tan x is negative because here's our original equation. So tan is negative in quadrant 2 and in quadrant 4. So if you sketch it out, there's your reference angle pi over 6. You rotate around, that's pi. So you can go pi subtract pi over 6, which is going to give you 5 pi over 6. Of course, you may also have chosen to memorize that value, or you can do it the way I do it, which I prefer. Don't like memorizing stuff. Here it is in quadrant 4. This is 2 pi, right? So you're going to rotate all the way around like this, and you're going to go 2 pi subtract pi over 6. So when you get a common denominator, that's going to give you 11 pi over 6, and there you have it, your 2 solutions. Hurrah, hurrah! Whew, there's 2 more here. I'm getting rather tired of doing these, so I'm probably just going to do 1. Which one looks more promising? There's this one here, which, I like that one. I might want to do that one. What's the other one we got? Yeah, let's do that one. Let's do part A. So there's another one over here. I'm going to leave this. But let's do this one because this looks like something you might see on the exam. So right, we got cosecant. So the first thing is, let's replace the cosecant with whatever it is. So remember, cosecant is 1 over sine. So we can write 2 sine x equals 3 plus 2 over sine x. Right, so when I substitute in 1 over sine x, I get 2 times 1. So there it is in the numerator. There you have it. Now I can go ahead and multiply both sides by sine x. I'm not going to solve this thing if I have the sine x in the denominator. Okay, so put brackets around everything and multiply everything by sine x. So don't forget to distribute into the brackets here. So on this side, you're going to get 3 sine x. And then sine x divided by sine x is 1, so you just get plus 2. And over here you get sine x times sine x, so you're going to get 2 sine squared x. And now we're going to have to factor. So move everything over to the left-hand side. So you get 2 sine squared x minus 3 sine x minus 2. And then you'd have a 0 on the right-hand side. So once again, I am not here to reteach you decomposition. You can go back and look at that lesson. So remember, you need to factor this. You're going to do decomp very similar to the last question we just did, right? Two numbers that multiply to a times c. So have to multiply to -4, but need to add up to the b term, which is -3. Remember, you can choose to rewrite this, like say let a equals sine x. Like if you just don't like staring at it, then you can plug it in and you can solve this, right? Remember, if you do that, you need to make that statement. Otherwise, you're going to lose half a mark. Okay, so when you factor that, maybe pause the video and then you can check my answer. But when you factor it out, you're going to get 2 sine x plus 1 over sine x minus 2. There we go. So once again, zero product property, solve both sides. So you get sine x minus 2 equals 0. And that's going to give me sine x equals -2. Now, please remember that our unit circle is defined from 1 to -1. Okay, so when you get something like this, and this does happen frequently on the exam, where they'll give you one of the branches, there are no solutions for this one. And you need to recognize that. So remember, basically at the end of the day, that your sine values have to land between -1 and 1. Same thing with cos. The only exception is tangent, which can have any value except for those non-permissible values, right? Over here, I like making that voice. We're going to solve for sine x again. So move the 1 over and you're going to get -1/2. This is looking like it's going to be an exact value for us, which is great. I'm very happy when we have them. So to get your reference angle, go inverse sine of the positive there. So +1/2. And you just got to think, well, where is sine equal to 1/2? And that's going to be at pi/6. Okay, now that's just your reference angle. You're looking for where is sine negative, so quadrant 3 and quadrant 4. So again, if you like doing the sketch like me, there's pi/6. You're rotating around like that. That's pi. Pi plus pi/6. That gives me 7 pi/6. There's one answer, and then over here, you're going to have the same scenario, except this is 2 pi, and you're rotating all the way around. So you're going to go 2 pi, subtract pi/6, and you're going to get 11 pi/6, and there's your two solutions. Yay! Guys, we did it. We made it. You can now try exercise 7.3. I'll post some supplements on Microsoft Teams or what have you. I'll also post them in the description of this video if you'd rather grab them from there. So it was such a blast having you again. Smiley faces for everybody. Yeah. And we'll see you next time. Bye-bye.